Hello everyone, this is gonna be the fourth C++ tutorial if I can count correctly. Yes, this is the fourth one. In this tutorial we're going to explain more about variables. So first of all, let me clarify something about strings because I didn't explain much. So let's say for example we're just printing any statement here with different chunk in it. Let's say this is statement number 1, something like that. Add some numbers, some letters, whatever you wanna add here, just add it. And then endl. Okay, so this in itself is a string here. What we can do, for example, of course, we can store it in a string variable also. In case you're wondering, with the spaces it will be stored with the spaces, with everything. So string basically stores any type of text here. So let's say string called sentence. Oh, and one more thing about naming the variables. You can, for example, add signs like this in the name of the variable. It will give an error. So let's say string called sentence, and it is equal to, let's say it's equal to this whole statement. Let me cut this out and paste it here. And now what we'll do is call the sentence variable like this, save it, let's run it. And yes, this works and it displays everything. So this whole sentence string stores all of this. Great. Another thing concerning numbers, integer, floats, whatever. So if we say integer x, this could be a positive or negative number in case I haven't clarified this also. And float y equal minus 3.6, whatever. So now cout, let's just display the variables like this. That's pretty useless actually, but in case someone is wondering if we can use negative numbers, we can. Okay, so as you can see, it's a negative number. Okay, so now we're going to discuss more data types, which aren't really that common in programming, but we have to know about them. So what I have here is a link to a page from tutorialpoint.com where it discusses the data types, has a chart for data types. I mean, it's already available here. I'm not gonna write it myself. I'm gonna leave a link to this page in the description. So here, as we can see, it shows the type of data types, the different data types, and this is typical bit width is basically how much memory it takes, the space it takes in memory. So as you can see here, because you know these variables, when you declare them, they are stored in a block of memory somewhere in our computer. So yes, they have width, space, they take some space in our memory. Not much space, of course, but here as we can see, characters, char, they store only 1 byte. Unsigned chars also 1 byte, signed char, we'll discuss a few of these. Here we have integers, they store 4 bytes. Now these integers range from the values, this number, to this number. Let me show you how. Let me just copy this number here. Let's say, for example, integer x equal, why did I delete integer x? Whatever, cout x, sorry, endl. So now let's run it. Okay, this works. Now let us try, instead of 7, just write 8, which is outside the range, and what will happen is, yeah, it will give the negative limit basically, or it's giving it a negative value. It's basically not knowing what the hell it is doing, so basically you can cross this limit. So this is the limits available here. Basically this is what they mean. Now unsigned integers, as I said in this tutorial, integers can range from negative numbers, let me zoom this out, from negative numbers to positive numbers. Okay, unsigned integers have more range in terms of positive numbers, but they can't be negative. So if you want to use an integer that's not negative, you can use unsigned integers, and they all store 4 bytes. Let us try unsigned integers. Something like this. Unsigned int x equal. Now let's try to cross this limit here. So we are having 9, and it will display correctly if I'm not wrong. Yes, it displays it correctly here. So exit. Okay, let's try giving it a negative number, see what happens. -2. Okay, and it displays some random number, so that means it's not working properly. So this is it here. Signed integers, short integers have less width and have less typical bit width. They store less space in memory, but the range is much shorter. You can view these and try them out. So here we have long integers, which basically have a very wide range, but they store 8 bytes. Signed long integers, okay. So you can see them here. They are all available. There is unsigned long integers, unsigned long, float. So basically what you'll see with decimal numbers, so these all were basically non-decimal numbers. Here in decimal numbers there are floats and double, long double, and whatever this is. Okay, so doubles, basically a double is the same as float, but it stores more memory space, and it gives more precision after the point. If we have a decimal point, basically, so as you know, float x equals 4 point whatever. Okay, double y. You can also write the same thing. Those doubles, they all display correctly. Now we can't actually explain what is the precision after the point. All what you have to know right now is doubles are more precise when we are doing complex calculations later on our variables. We are doing complex calculations. It will be more precise when it calculates the decimal numbers after the point, after the decimal point. But now we haven't even discussed how to calculate stuff in our code, so I can't explain much more than that. But if you saw a double, just know it means something like float. And in case you are actually wondering about these sizes here, we can check them out actually using a built-in function. Now don't worry too much about these built-in functions. We're going to explain what functions are in coding later on. But there is a function that basically displays the size of a character inside, the size of a variable, sorry, inside our memory. It's called something like this, size of x, which is a float, sorry, small x, not capital X, and not double x, and not equal. Okay, size of x, let's copy this. Size of y, in case you want to check them out, just you write size of, and in brackets you put the value which you want to know the size in memory. So let's run this. So as you can see, 4, 8, which is true. If we check here, float are 4 bytes, double are 8 bytes, and yes, that's it. Okay, then one more thing we're going to do is basically, let's say here, let's display this in a much more beautiful way. So you can say something like store this in a variable, these in a variable. Let's say int size 1 is equal to size of x, and then size 2 is equal to size of y. And now let's just call on size 1. Okay, no, don't do that. Okay, size 2, and run this code and it will work perfectly. Okay, so here if you want to decrease the memory storage, you don't have to do that, but as we can see here, there is These are basically numbers, small numbers. We don't have to store all this much space in our memory, so we can use something like short int, which is 2 bytes only, or even unsigned short ints, because the number will never be negative. So let's store them inside unsigned short integer. Oh, okay, integer is already written. Short integer, and let's just display the size of cout. For example, size of the size1 variable, which will be 2. Let's run this code. Okay, so 4, which is displaying the size of x, which is a float. 8, which is displaying the size of the double, which is y. And then size of the size, which is displaying whatever. You get it. The unsigned short int size1 will be of size 2. So yes, that's it for this tutorial. Thanks for watching. See ya.